everyone, this is Mrs. Musoff here. Today we're going to be going through talking about outliers and how to calculate them algebraically instead of just guessing that they're outliers or not. Okay, remember outliers, those are the really high and really low numbers that don't really seem to fit with the rest of the data. Okay, so this first problem says the Environmental Protection Agency, the EPA, is in charge of determining and reporting fuel economy ratings for cars. In 2008, they changed the method for measuring a vehicle's fuel economy to try to give more accurate estimates that consider air temperature, air conditioner, driver use of the gas, and brake pedals. The table below gives gas mileage, so that's what we're talking about here, gas mileage. Whoops, there we go. For a sample of 24 2012 mid-size cars, and that's what all this data represents. Okay, and we talked about in class gas mileage, that's like miles per gallon. Okay, so if you haven't already, type this into your calculator, and that way you can make sure to follow along. Feel free to pause the video if you need to take a second to do that. Okay, otherwise we're going to get started. So number one, it says calculate the average and the range of gas mileage for this sample of cars. Well, average, you could do it by hand and just add all these up and divide by the 24 cars that we have here. But since I'm going to have to find the 5-number summary later anyway, I figure it's easiest to already have it in my L1. And I'm just going to go to Stat, Calc, and it's number 1, which is one variable statistics. And if you have my calculator, you just scroll down. If you have the other one, you can just press Enter. All right, and there's all our data. So remember, the mean is the one with the bar over it. That's this first one, 29.083, we'll say. 29.083. And it's important to understand what that number represents. So since all of these other numbers are talking about gas mileage or miles per gallon, the average or the mean is the exact same thing. It's still just miles per gallon. It's just the average amount. So I'd say 29.083 miles per gallon is the average gas mileage. That way we still know exactly what we're talking about. Alright, the range is not something you'll be able to calculate on your calculator, but we will use some of the information on a calculator because the range is the max minus the min. So my max is 48 and my min is 18. So max minus min, 48 minus 18. So here that would be 30. And again, that still represents miles per gallon. But range isn't the average, right? Range is a difference because we subtracted, so it's the difference, 30 miles per gallon difference between the highest and lowest gas mileage. Between highest and lowest gas mileage. Oops, there we go. Alright, so we've got a couple of values here, and then we can calculate our 5-number summary, and that should be, again, from our calculator. So if you scroll down, you should be able to see all 5 numbers. They're right here, 18, 26, 28, 31, 48. 18, 26, 28, 31, 48. Okay, to make our box plot, you can do this partially on the calculator, or you can do it by hand. Once you have the 5-number summary, it's not too difficult to do it by hand. But just to show you how to do it on the calculator also, first thing you're going to do is go into second y equals, your stat plot. Make sure one of them's on, and press the one that is on. And for now, we're going to be on the second box plot, so the one that has the line in the middle with no points. That's the one we want to be on. All right, and then if I press zoom and scroll down to number 9, which is stat, that's what will give me my box plot. If you want to be able to see the 5-number summary on there, just press trace, and you can move along it, and it'll give you the value on the bottom. Okay, when I draw mine, I'm going to want some labels, so I might as well just draw it by hand. There's my axis. My smallest is 18, so I'm just going to start at 15 and go by 5s. 20, 25, 30, 35, 40, 45, and 50. And remember, these numbers, all of them, all represent miles per gallon. So that's what I'm going to write for my label. Alright, now I'm going to plot my numbers. 18's about here, 26, 28, 31, and then 48 way out here. And our box plot, you form the box, the rectangle, from your middle 3 numbers with a line through the median. and we draw a line from your minimum to Q1 and from Q3 to your maximum. Okay, and the only thing left is a title, and this is talking about the gas mileage of 24 2012 mid-size cars. So that's what I'm going to write, gas mileage for 24 2012 mid-size cars. So there's my box plot. Okay, now here's the new stuff that we're going to be talking about today. We talked about range. IQR is a type of range. The one problem you might have noticed with range, like right now our range is 30, which is kind of a big difference when you're talking about gas mileage. But maybe that's only because we have such a large maximum and such a small minimum, and that's kind of skewing things because it makes it seem like there's this big difference, when really there's only a couple numbers that are out there that far. So we have another value that is not impacted by outliers. It is resistant to outliers, just like the median, because it only looks at the middle half of your data. So we don't really care what's happening on the ends for the IQR. And the IQR stands for interquartile range, but instead of doing max minus min, the IQR does Q3 minus Q1. So that way it's not affected by those really big and really small numbers because those are out past Q3 and Q1. We're only focused on the middle values. So to calculate the IQR, I would do Q3 minus Q1 here. Let me scroll up. That would be 31 minus 26, which is equal to 5. So there's a 5 mile per gallon difference in the middle set of our data. Okay, and actually we use this number for more than just describing how far apart the data is. Like right now, because that IQR is 5, so small, that gives us a pretty good idea that most of the data is pretty close together. There are just a few numbers that make the range look like it's spread apart. But this number also does something else for us. It can help us determine if a data point is an outlier. Okay, an outlier, data point's an outlier if it's bigger than, and we have a little formula for you, but I'll explain it. Bigger than, we start with Q3, and you add 1.5 times the IQR. So think of this value. You're like, ignore the Q3. Think of this number right here as a constant. You're going to add that on to Q3 and then put a fence down. And that fence will tell you any points outside of the fence are outliers. Okay, but a data point can also be small, a very, very small data point, and be an outlier. So if it's smaller, then instead of Q3, we would do Q1, and instead of adding, we would subtract. Okay, so again, think of these values, these numbers, they're like the fence. Any numbers in between the fence, you're good. Anything outside of the fence is an outlier. So let's try calculating it here. Okay, number 5, it says you can see from the box plot that the data set for gas mileage of the cars have several outliers in it. Well, I'm going to show you exactly how you could see that on your calculator. But first, let's show our calculations for verifying that there are outliers. Alright, so I'm going to start with my higher end outliers, and then I'll do my lower end outliers and check to see if we have any. So for the higher end, again, we're going to use this formula. Q3 in this case is 31 plus 1.5 times the IQR, which is 5. Now either do this in your calculator or remember to multiply before you add, okay, whichever one you would prefer to do. You should end up with 38.5. And what that means is any data higher than that are outliers. So you can take a look back up at your data and see if there are any bigger than that. Let's see, I see a 40 and a 48. So there are 2 data points right there that are outliers. So I would say 40 and 48 are outliers. And then I check my lower end. So lower end starts with Q1 instead, which is 26, and we subtract 1.5 times the IQR, which is 5. Again, use your calculator or multiply before you subtract. And this should get you, let's see, I believe 18.5. So again, this is our lower end, so any data lower than this, that's our fence, are outliers. And just one little side note, if it lands on the fence, an exact point is at 18.5 or 38.5, it is not an outlier. So it has to be outside of the fence. Alright, so I'll go back up, I'll look, and I'll see, oh, there's an 18. And I think that's it. So we do have a lower outlier as well. 18 is an outlier. So there are 3 outliers in this data set. Okay, now before it said you can see from the box plot. That's what I'm going to show you real quick, that you can actually check it out on your calculator and see exactly what your outliers are. So if you take out your calculator, follow along with me so you can make sure you understand. We're going to go back into the stat plot, second y equals, and into the one that's on. But remember how there's that other one that kind of looked like a box plot? Those dots that you see are actually outliers. So if you select that type instead of the further one, it'll tell you exactly what your outliers are going to be. So if I zoom 9, now these little boxes are my outliers. And if I press trace, I can figure out exactly what numbers those are. Alright, so the idea is when you graph it on the calculator, from now on you should be using this type of graph so you can see if there are any outliers. But then a lot of times in your homework we're going to ask you to verify it using calculations. So just make sure you know how to do it by hand and on the calculator. Alright, go ahead and flip the page over. Just a few things to talk about. It says, look up information about the cars that are outliers in the data set. Well, we're just going to talk about this a little bit so you can kind of see what the deal is with these outliers. So I have them circled here. Let me just highlight. These are the numbers with the higher gas mileage, and this is with the lower gas mileage. So usually knowing that they're outliers gives you some ideas about those cars. For example, the Bentley gets really low gas mileage. Well, maybe that's because it's a Bentley, which means it's a pretty powerful car, so it requires a lot more gas in order to make it that powerful. Right? Toyota Prius has a really high miles per gallon. Maybe that's because it's a hybrid. Usually hybrid cars don't take as much gas. That's the whole point. Alright. Hyundai Elantra is actually an interesting case. It could be maybe part hybrid, or maybe the company was trying to kind of fudge their numbers, because usually you wouldn't think that a car that's not a hybrid would get such high gas mileage. You never know, but that's the idea of statistics. It gives you some things to predict. Okay, now number 7, it says remove the outliers from the data set and recalculate the mean, the range, and the 5-number summary. So I'm going to help you out with this. I'm just going to show you how I would do it on my calculator. I go back into edit. I'm going to find those numbers, and I'm just going to delete them out. So 18 I deleted. There's 40 I'm going to delete, and then 48. There it is. And if I go back into stat and calculate my one variable statistics, I'll get some slightly different numbers. Okay, I see my mean went down a bunch. It's 28.19 now. 28.19. I've got my 5-number summary. But one thing I want you to notice, there are a couple numbers in that 5-number summary that change significantly. The min and the max, for example, 23 and 34. But there are some numbers in there that really didn't change at all, or if they did, just barely. And that's Q1, median, and Q3. 26, 28, and 30.5. And the reason that these numbers didn't change is because they are not affected by outliers. So by removing the outliers, it didn't really affect that much. Now, it did change it slightly, and that's because we took 2 outliers from one end and only 1 from the other, but it still did not change it significantly. And that's what's supposed to happen, because these values should be less affected by outliers, unlike the minimum and the maximum, right? And the range, same thing. If I did max minus min now, I would get 11. That's way lower than it was before, and it's because of those outliers. Alright, well, I've got a little summary written down here, so I'd recommend maybe pausing so that you can jot some of this down. But it's just exactly what we've been saying, just a little summary. The mean and range are affected the most by outliers. The median in Q1 and Q3 didn't change, or changed just barely, because those are based on the location in the data set. They're more resistant. And overall, if a data set has outliers, make sure to use the median and the IQR as your description.